So in today's video we will be looking at an example of series and parallel resistors, and here we are given an example with some parallel and series resistances, and we are required to find the equivalent resistance. In other words, a single resistor that represents all these resistances, such as that. Okay, so the formulae from the theory videos for series and parallel are given here. For series, the R equivalent is just the addition of all the resistances. The voltage over the nth resistor is the nth resistance divided by the addition of all the resistances times VI. For parallel, R equivalent is 1 over each resistance added all the way up to Rn inverted. That gives you R equivalent. So in other words, to the minus 1. I don't know if you can see that. And the current through the nth resistor is 1 over Rn divided by the addition of all the resistances 1 over times the current. I think I forgot to say that in the theory video, so please just take note of that formula. Okay, so let's calculate the equivalent resistance. So how do we approach this problem? Well, we have formulae for n equivalent resistances for both parallel and series. So what is parallel? Parallel is when two resistors connect to each other on one side and connect to each other on the other side of the node. So here we can see that 60 and 80 are in parallel. So we have to find an equivalent resistance for that. And let's just add in an extra resistor here to add some trickery to it. And we can see therefore that these three are parallel. And we can also see that the 20 and the 80 are in parallel at this stage. So what we're going to do is we're going to work from the inside out, because we have to work out these, and then only can we consider the resistors outside of this area, because otherwise we're not going to have an equivalent resistance here. We're not going to be able to add anything. It just makes it a lot simpler. Okay, so how we write this is we say 60 is parallel to 80. Parallel is represented by those double lines, is parallel to 80. And we're going to say this is equal to this is R equivalent, but this is equal to 1 over R1 plus 1 over R2 plus 1 over R3. There are three resistances inverted. And this is equal to 1 over 60 plus 1 over 80 plus 1 over 80 to the minus 1. This is R1, this is R2, and this one is R3. Okay, and that gives us 24 ohms if I calculated correctly. So now next we're going to say, okay, well, we can also calculate the equivalent resistance of this little block here. So we're dividing it all into little blocks. They're connected by that node and they're connected by that node, which means they're in parallel. So there's a little trick with resistances that are of the same size. 26 parallel 26. So how we do this is we say if two resistances are of the same size, then the equivalent resistance is half of one of them. So in other words, half of 26 is 13, so the equivalent resistance is 13, and one can write it out like this. So 1 over R1 plus 1 over R2 to the minus 1, and you'll find that this gives us 13 ohms. Okay, we can also find the 20 and the 80. So 20 parallel to 80 is equal to 1 over R1 plus 1 over R2 in this case to the minus 1, which is equal to 1 over 20 plus 1 over 80. And if you put that in on your calculator, it is 16 ohms. So now we're going to redraw the circuit first so that we can see exactly what's going on. So let's do that here. So we have point X and we have point Y, point X and point Y. And the equivalent we found so far, the 226's gave us 13. The 60, the 80 and the 80 gave us 24 ohms. This 20 and the 80 gave us 16 ohms. And don't forget that this part is still parallel to 40 ohms. From there, you can see it connects to the same nodes. And we have this 7 ohm resistor in series with that. Okay, so there's our equivalent circuit so far. So now we can say, okay, well, 24 plus and 16 are in series because they're connected to by one node, which means R equivalent equals 24 plus 16, which if I write it in the formula is R1 plus R2, and that gives us 40 ohms. Now I can redraw it again. 40 ohms parallel with 40 ohms in series with 7 ohms to point Y. So 40 and 40, remember we said that two resistors in parallel give us half of the resistance. So R equivalent, let's call it R equivalent A in this case, is equal to 40 over 2, which gives us 20 ohms. So our equivalent circuit thus far, 13 ohms in series with 20 ohms in series with 7 ohms to point Y. And if we add that up, we get R equivalent, because it's all in series, is 13 plus 20 plus 7, which gives us 40 ohms. So our R equivalent is 40 ohms.